Good morning, everyone. Today, I'm going to explain my project with the title of Maze Navigation by Quantum Robot. In brief, a new quantum algorithm will be developed to solve the maze. In this project, the type of maze is said to be the tree-diagram maze as shown in this figure. There are several requirements or standards for the tree-diagram maze. Firstly, the tree-diagram maze must be a single starting but multiple destinations maze. Secondly, each junction must have two following possible paths. And thirdly, the junctions will be classified in layers. For example, this junction is classified as the first layer junctions. These two junctions will be classified as the second layer junctions. And these four junctions will be classified as the third layer junctions. The tree-diagram maze is a common 2 to the power of n exponential growth problem. When the number of layers increases, the number of possible paths will be increased exponentially with the value of 2 to the power of n. For example, one layer maze will have 2 possible paths. Two layers maze will have 4 possible paths. 20 layers maze will have 1 million possible paths, and 50 layers maze will have 1 quadrillion possible paths. So, if the maze navigation is improved to be navigated between two countries, the more layers will be in between. And the biggest concern will be the computational power. In this project, the focus point will be the difference between the classical computing and quantum computing in solving the tree-diagram maze. The main difference between the two computing is their basic unit of information. A classical computing uses the bits as the basic unit. For one classical bit, it can either be 0 or 1, so that there are only two possible states. However, on the other hand, the quantum computing uses the qubit as the basic unit. For one qubit, it can be exactly 0 or 1 or any values in between. For example, the qubit can be in the form of 10% of 0 and 90% of 1. Thus, it is expected to have infinity possible states for a qubit. In summary, the quantum computing will rely on a lot of possibility stuff. To find the shortest path of the maze, firstly you must know the length of all possible paths. Theoretically, the basic classical way to find the length of all possible paths is to find them one by one. For example, solving one layer maze requires 2 steps, which are finding the path 1 length, the path 2 length. For the two layers maze, you have to find the path 1 length, path 2 length, path 3 length, and also the path 4 length. Therefore, the number of computation steps for classical computing will be 2 to the power of n when there is n numbers of layers. On the other hand, for the new invented quantum algorithm, it will fully utilize the possibility features of the quantum computing. Therefore, a ratio-based approach in finding the maze is used. The ratio-based approach is basically calculating the possibility of going left or going right per layer. For example of one layer maze, it will only require one step of finding the layer 1 possibility ratio. For two layers maze, it will only require 2 steps, which are finding the layer 1 possibility ratio and also the layer 2 possibility ratio. The quantum computing can be realized by importing the Qiski open source library. By using the Qiski, it can build the quantum gate circuit and solve the maze. For different scenarios, it will have different combinations of quantum gate circuit. So this is the quantum circuit built from the Qiski. By running the quantum circuits, it will calculate the possibilities of all possible paths and show the shortest path with the highest possibility. As the results, the output results from the quantum algorithm will decode as the classical results. Therefore, it will be fully compatible with any classical devices, so that you don't have to buy any quantum devices in order to use the output results from the quantum algorithm. Moreover, by using the new invented quantum algorithm, it has a 100% successful rate in controlling the robots. Secondly, it will produce a top 9% of the shortest path among the possible paths, which will contribute to a 91% of score or accuracy in the maze shortest path ranking. Most importantly, it will have a 80% slower time increment per increasing one layer. After that, let's talk about the potential of the project. Firstly, the quantum computing market is large. Based on Kyrie in 2021, she stated that the quantum computing market will increase to 64.98 billion US dollar by 2030. In the last few years, the top leading countries such as the United States, China, Germany, and Japan have spent tons of money on quantum-related research. Secondly, until today, there is still no sign of any implemented quantum-based navigation in the world. Therefore, being the first or leading in this area is always good and full of potential. Lastly, there might be a high possibility that the mass navigation companies such as Google Maps, Baidu Maps, and Waze will be interested in the idea of this project. Suppose one of them can master quantum computing in mass navigation. In that case, it is undeniable that the company will be the top leading company in the next few decades among all competitors. In summary, this project is full of benefits. Firstly, it will benefit the environment. Using quantum computing will require a lesser computation time, which will directly lead to a lesser power consumption. As we know, most countries are still using unrenewable resources such as petroleum or coal to generate electricity. Most of the electricity generation will produce greenhouse gases that are bad for the environment. Therefore, a lesser power consumption will directly contribute to a lesser demand for electricity generation, which will eventually reduce the emission of greenhouse gases. Secondly, this project will benefit the people or human beings. By having faster navigation, it will be time-saving and extremely convenient. Lastly and most importantly, this project will help in the quantum society. People from the quantum society can learn or reference to this new quantum gate circuit approach algorithm in their future research. With more people researching and helping each other in the quantum computing that is beneficial can be matured very soon. In the end, thank you for spending your precious time watching this presentation. I hope that you will like this project. Thank you very much.